So, uh, I was thinking that no, we will continue with our complex number journey and then make sure that we finish that unit, which is unit 3 of pre-calculus. But then there is something about so we learn about the complex number. Uh, there are different forms in which you can represent a complex number. One is called rectangular form, and another one is called polar form. And polar form is something that we would be able to understand better if we are well versed with the unit circle. So that's why I thought, no, let's take a step back, come back to unit circle, because unit circle is something that we will be needing to understand quite a lot, not only for a complex number but also for having a better understanding of trigonometry as well. So that's why we are just pausing complex number for a day. We will finish the understanding of unit circle and then we'll go back to complex number. Is that sounding okay to you guys?
Yes.
Okay. Dave, are you okay with that? Okay. So, and my request to you guys would be keep your audio, keep yourself unmuted so that we can have better interaction. Unless there is a background noise that we are in, but yeah, more we interact, better it is, because just the emojis, thumbs up, doesn't connect us well as student and teacher. All right. So, first of all, what do we mean by unit circle? What is your understanding of unit circle? Anybody? Be it Prisha, Dev, Dhanushri, anybody? At a very high level.
It has like different radians and stuff like that. I'm not really sure.
Okay. You guys are much more intelligent than me, for sure. I look at things in a very simple, easy way. Let's see if Prisha wants to define it. Prisha, any thoughts?
The unit circle just has a radius of 1, and it's like helpful in trade, I guess.
Yeah, I mean that would be another simple way of looking at it, right? I mean, if you look at any circle for that matter, if I have a circle, what are the key elements that define a circle? Primarily the radius. That's the only thing, correct? So when you're saying, I'm sorry?
I was just going to say like radius and diameter.
Right. So radius and diameter. I mean, radius and diameter are both related. So I would not treat them two different things. Radius, diameter is just 2 times of a radius. But as long as we know what is the radius of a circle, that gives us all the possible information that we would need for dealing with a circle. Correct? So when you say a unit circle, you are saying that a circle which has its property as a unit, and the best property of a circle is the radius. So the radius is 1. So now it's connecting the dots, right? I mean, unit circle is a circle with unit radius, as simple as that, right? And most of you know, I was just trying to articulate that in a way that it kind of sticks with us, yeah? Now let's look at the circle a little bit later. We'll come back to this one, but let's go back to something that you guys have learned pretty much in detail at a little younger age. I mean, obviously you guys are much younger than me, but I'm saying when you were younger than yourself, you would have come across this basic cute looking triangle called right angle triangle. And then you would have learned about a theorem called Pythagorean theorem, which says a square plus b square equal to c square. Yeah. Now, if you let's go to a point where let me go back to the circle again, so that way I can relate these two things together. So let's say this is my radius. Okay, this is radius, and this is my circle. What I'm doing is, let me join what I've done is I have dropped a perpendicular from this point to this horizontal axis and made this a right angle triangle. Now, if you visualize this in a coordinate plane, so this is a circle, this is a circle, this is a radius, and I'm saying this is my origin where this is where the center is located. And now from this point on the circle or the perimeter, I have dropped a perpendicular. So let's say this is O, let me call this as A, and let me call this as a B. So the triangle OAB that you see is nothing but a right angle triangle. No questions? Or any questions?
No, sir.
Okay. Now, so here by the Pythagorean theorem, you know that, okay, if this is, let's say, A and this is B, let me call this X because this looks more familiar to us when we visualize this in a coordinate plane. So this is my x-axis. So let's say this length is X, and this is the vertical distance which is along the y-axis. So let's call this as Y. Yeah. So my Pythagorean theorem says that x square plus y square equal to r square. So far, no confusion. This x square plus y square equal to r square. Yeah.
Yes.
Prisha and Dev, are you guys okay with whatever I've said?
Yes, sir.
Okay. Now I'm saying this is a unit circle, meaning this is not r. This is actually 1. Oops. I need to change this board soon. So I'm saying this is a unit circle, meaning the length of the radius is 1. So I'm not going to say r square, I'll rather say 1 square. So now you should connect all the dots. First of all, what is a unit circle? You know, radius is one unit, be it meter, be it centimeter, whatever, it's 1 unit. Now, on that unit circle, I have put a point on the perimeter and dropped a perpendicular from there to this horizontal axis, which is along the x-axis, and saying this is y, this part is x. Basically, this is nothing but my x coordinate value, right, for this point, and this length tells me the y coordinate value. So if I'm looking at this whole thing with respect to a unit circle, what we are essentially seeing is x square plus y square is 1 square. So basic definition of unit circle, then relating that with the Pythagorean theorem. So this is the point we have come to. So far, any doubt?
No, sir.
No.
No, sir.
Okay. Now let's add a little more color to it. So I was saying that you guys have dealt with this cute looking triangle called right angle triangle. Now let's add more flavor to it. So let's say if this is the radius, this point is making, let's say, angle theta with the x-axis. Yeah, this is making angle theta with the x-axis. If I would have taken, let's say, a point here, that would have made a different angle. No, I'm saying this is a angle theta. We don't know what is the value of theta right now. Just the angle theta. Okay. Now by sohcahtoa, you would know if this is my angle theta, sine theta will be how much? Here we know what is my x and y. So sine theta will be how much? Anybody? This is angle theta, this is y, this is x, and this length is 1. And this is looking like a right angle triangle. So I'm saying if I have to find out the sine of this theta, what will be the value with respect to what you see on the board?
Would it just be y over 1, which is y?
Spot on. Yeah. So basically, as you know, sine theta is whichever angle you take, sine of that is the side opposite to that divided by the hypotenuse. That is your sine theta. Similarly, if you say cos theta, will be equal to, cos theta will be equal to the side, which is the base, divided by the hypotenuse, which will be nothing but x divided by 1, x divided by 1, which will be x. Yeah?
Yes.
So now look at this. There's another thing that we could relate. If you look at this is a unit circle. This x is nothing but, we found that this is x is equal to cos theta, and y is nothing but sine theta. So one thing that we have always learned or heard, you would have probably heard it at least 1,000 times. Sine square theta plus cos square theta equal to 1. That's something that we have been told 100 times, right? I mean, you would be knowing it, correct? See, you see a practical proof of that right in front of us, right? See, if here in this unit circle we say, okay, this square plus this square equal to this by the Pythagorean theorem. This part we found as cos theta. This part we found as sine theta. So x squared plus y squared will be equal to sine square theta plus cos square theta equal to 1. I have done nothing. I have just substituted the value. I have just related the basic concepts that we know. We looked at it and we found this. Is it sounding okay or sounding a little different? So basically, this now if you come back to this one, if you're talking about any unit circle for that matter, the x component of the unit circle, or the x coordinate of any point on the perimeter of the unit circle would be x cos theta, and y coordinate of any point on the perimeter would be sine theta in case of a unit circle. So this weekend I need to go shopping. Just 1 second. Okay. Shopping as in just buying this board. Nothing very fancy. Okay. So now, sorry for this one. If you guys give me just 1 second, I'll be back with a fix for this one. Just 1 second. I'll go with okay. Sorry for all the trouble. No, it should not come now. So when I upload the video of the class, this part of the video, you can certainly skip. Okay, so now what we have seen so far is if you're talking about a unit circle, if I'm talking about a unit circle, any point you take on the perimeter, you can find out the x and y coordinate of that point, and you can always relate that. So any point, you will always assume that your center is the origin of the coordinate plane. Okay, and then this has two parts. This is the vertical length and this is the horizontal length, and you will always connect this point and find out, assume this as theta. So this part, if this is your x coordinate and this is your y coordinate, so the x coordinate, so this will be x and y, and you know that x is nothing but cos theta and y is nothing but sine theta. So in a unit circle, the coordinate of any point on the perimeter of a unit circle would be cos theta, sine theta. And again, if you are not able to recall what we discussed, this is your x coordinate, cos of theta. Since this is 1, so x by 1 is cos theta, y by 1 is sine theta. Make sense?
Yes, sir.
Okay.
Yes, sir.
So now whenever you are dealing with a unit circle, any point that you pick up, you have to look at, okay, let me take a quick pause. Now another thing you must be knowing is, if you look at this whole circle, how much of an angle it makes? 360 degrees in degrees, and in radians, how do you measure the angle of the entire circle? How many radians it has, a circle has? Like I said, 360 degree for the in degree, in radian, how much it is?
2 pi?
2 pi, yeah. So every 180 degree is nothing but pi radian. Okay, so whenever you are dealing with a unit circle, you have to always keep two things in mind. One is your radius is 1, and second thing is, this is nothing but a coordinate plane, and you will have to get the absolute value of this length of along the y-axis, absolute value of the length along the x-axis. That will be your x and y coordinate value, and then you have to look at which quadrant you are falling in. Let's say if I say find out the x and y coordinate of a point on a unit circle where theta equals to 45 degrees. If I say theta equals to 45 degrees, you will say that means it is in first quadrant, meaning the value of x and value of y both will be positive. So what you will do is, you will find out cos of 45 degrees is how much, which you would remember or recall is 1 by root 2, right? Similarly, sine of 45 is also 1 by root 2. So you will say this will be my x and y coordinate for angle theta equal to 45 will be 1 by root 2, 1 by root 2. If I say find out the x and y coordinate where the angle is 225 degrees, right? You have to find out the x and y coordinate, meaning you're talking about completing 1 pi here and then traversing in clockwise direction for another 45 degrees. So here to here, when you move, this is still staying on the flat horizontal line. So there is no vertical distance, there is no y coordinate that you can find out. So what you will do is, okay, fine, 180 is taken care, it's a horizontal line, I'll not worry about it. And this is where it's making this 45 degrees. Now look at this triangle, find out the absolute value of this length and this length for the 45 degree, which is again 1 by root 2, 1 by root 2. Now you know this is falling in the third quadrant where x, the value of the x coordinate, it's a negative value along the x-axis, it's a negative value along the y-axis also. So your coordinates for this point with 225 degree is going to be both negative. So it will be minus 1 by root 2 and minus 1 by root 2. So there are different ways of doing it. People calculate in different possible ways. What I'm saying is, don't worry about it. Find out what is the angle along this horizontal axis. Find out the absolute value, this length and this length. This absolute value will not change. This is just a right angle triangle for us. This length and this length will not change. So find out the absolute value and then you figure out which quadrant it's falling into. If it's falling into third quadrant, both are negative. If it, let's say, if I'm talking about 270 plus 45, 315. If I'm talking about this, so essentially 315. So this is 180, 270 plus 315. What I will do is, I will again look at this angle. Now total is 360, 315 is covered, so this is 45 degrees. Look at this 45 degree, find out this length and this length, absolute value, and then look at which quadrant you are in, and based on that you can you will put the sign. So here your the x coordinate value will be positive because this is along the positive direction of the x-axis, and y coordinate will be negative. So basically your for theta equals 315 degrees. My coordinates of the x and y coordinates will be again 1 by root 2 and 1 by root 2. And then my x value is going to be positive, so I will not touch that one. My y value will be negative, so this one. So this is how you can always visualize this unit circle as a coordinate plane, the 4 quadrants. Find out the absolute value, applying the Pythagorean theorem or whatever that we are going to learn with respect to the trigonometry part of it. Once you find out the absolute value, then you find out how does it relate to the actual sine of the x and y coordinates. So is it making sense, Tanushri, or I'm creating more confusion?
It's making sense.
Dave, I think Prisha got okay. I thought I bored Prisha enough to drop off. So
Oh no, you're shut off.
okay, no. So whatever we have discussed so far, are we clear about that?
Yes.
Okay. So summary is, unit circle is not coming from anywhere. It's just an extension of what we know. It's just an extension of our knowledge of Pythagorean theorem, the basic understanding of trigonometry, and then clubbing that with the coordinate plane. If these 3 concepts are clear, dealing with unit circle is not going to be something that will bother us. Are we all clear? Dhanushri, any other related question that you might have, you or Prisha or Dev, on unit circle before I move on to something else?
No, sir.
No. Prisha, Dev?
No, I don't have any.
Okay. So Prisha, for you, I know you wanted to cover trigonometry, right?
Yeah.
Which is the unit 2 of this one, which we have covered before. So I'm not sure if you got a chance to see my messages in mom's phone. I had given the link of all those classes. Maybe you can, whenever you get time, you can use that video to revise once. Just go through it once. Or
I watched a couple of them.
okay.
I just didn't get the time to practice yet.
Okay, so now since you have watched it, now that gives me a reason to ask you what are the concepts that you have learned and where you think there's something that I could be of any help.
I just went over the first first two unit circle ones, the first part and the second part, and so far I understand
Okay.
everything you said. I'm sure I'll have more doubts as I watch the other two.
Right. So my only recommendation here would be watch those videos, and then you can also go to Khan Academy Unit 2 of Pre-Calculus and try doing the unit test part. So whatever I vomit in the class, right? I mean, you have to see if those things are helping you solve the problems in the unit test without going through this content by yourself, right? Without going through Khan Academy yourself. And if it makes sense, then you try finishing the unit test, and if you get stuck anywhere, that gives me another opportunity to kind of clarify things which is needed. Yeah.
Yeah.
And whenever you get time, just read those messages that I had sent. I had given some options also only for you. Okay. Only for you, as in because Dev and Dhanushri have probably gone through the trigonometry concept. So Tuesdays and Thursdays when I'm out, we can always discuss. I mean, I'm totally jobless for 1 hour on both the days. So you can give me a call. We can discuss. Or I can join the Google Meet. Just that I'll not have a board in front of me, but I'll certainly be able to explain a lot of things. Yeah.
Yeah.
All right. So this is on the unit circle. Now, going back to complex numbers. Are we good, Selvi? Because there are few things in complex numbers that we have to finish before we can claim that we have covered that unit, and then we'll move on to the fourth one. And Prisha, for you, whatever units we have covered before, what I suggested, that will be the approach for now. But it doesn't mean that I'm not going to come back to those topics. Okay, so whenever we find a genuine reason, when the whole class says that, yeah, let's do it one more time, I will do it. Regardless, once I finish all the remaining 8 units, then I'll again do a second iteration of this one in the same class. So any which way, we will be making sure that none of the topics are left unattended. Yeah. Now, let's go back to complex number. So we talked about what is a complex number, what is the real part, imaginary part. We learned how to multiply complex numbers, how to divide complex number, what is conjugate, all that, right? So interestingly, one thing that you would have seen, that every complex number that we talk about, it's in the form of a plus bi, right? Where a is the real part, b is the coefficient multiplied with the imaginary part of the complex number. Yeah.
Sir, I have to leave early. Is that okay? I'll watch the video.
Sure. You're fine.
Sorry. Thank you.
No worries. So, Dave, Prisha, both are with me?
Yes, sir.
Okay. So, any complex number that you look at is always in the form of a plus bi. Yeah. This is the real part, and this is the imaginary part of the complex number. And if you look at it with a more holistic approach, you can imagine that any and every number that we come across can be called a complex number. Let's say if I say 5, is this complex number? Yes, it's a complex number because it has an imaginary component multiplied with 0. So, for the sake of simplicity, we will not call every number as a complex number, but when it comes to relating something, if somebody says, is a real number also a complex number? Yes, it's complex number is a superset. Every number falls under that superset. Okay, so this is just 5 also can be qualified as a complex number, just that its imaginary component is is multiplied with 0. That's it. Yeah. So coming back to this one, so this form of representation of a complex number is called the rectangular form. Why? Because we visualize this in a coordinate plane which has a horizontal and a vertical axis, right? It's called a rectangular form. So you can always represent a complex number. The standard representation of a complex number, which we never called as a rectangular form, is actually a rectangular form. Yeah.
Yeah.
Now there's one more form which is called polar form. Have you guys heard about that form by any chance?
No.
How about you, Dev? Dave, did I make you sleep? Dave, if you're talking, you're probably on mute. Okay, so I'll probably take that as a no. Polar form. Now, see, that is why I went back to unit circle. There was a reason to it. Now, if you look at this, let's say this is my unit circle, and this is my x and y coordinate. So this is in unit circle. Since we are talking about complex number, we will look at this as a complex plane, meaning this is my real axis, this is my imaginary axis. Okay. If in a unit circle, if I pick up a point here, okay, then if I, okay, just 1 second, you guys got logged out. Now, in this unit circle, we know that this is 1. Fine, understood. This part is nothing but your real component, and this part is nothing but your imaginary component. And if this angle is theta, see, we are mixing two things right now. We are looking at unit circle and we are comparing that with a complex number, and we are relating that in a complex plane. So this, instead of y, this is my imaginary axis, so this is b. Now going back to what we saw, right? Any point, the x coordinate is cos of theta and y coordinate is sine of theta. So here you will see that this is nothing but cos of theta and this is nothing but sine of theta. So you can represent this in the form of cos theta, which is a, plus I sine theta. So this is nothing but your polar form. Here, only difference, we just related that with the unit circle. Now, let's forget that this is not a unit circle. This has a radius. In that case, what happens? This A is nothing but, now let's take a step back. We'll probably come back to this one more time. We'll come back to this in 2 minutes. Now, when this is not a unit circle, it's a regular circle. This is my real axis. This is my imaginary axis in a complex plane. So, in that case, it is theta. A by r is cos theta, and B by r is sine theta, right? So A is equal to r cos theta and B is r sin theta. Okay, so you can as well substitute it here and you will say this is r of cos theta plus r of b, r of sin theta I. So when you represent this in the form of a trigonometry or comparing that with the circle theorem, you will see that this gets represented little differently, and that is nothing but called the polar form of complex number. Let me just stop here for 2 seconds to see if you guys are with me or I lost anybody. So summary is, you can see unit circle is nothing but when your circle theorem is there. Yes, you have a circle, you can find out x and y coordinate in a coordinate plane against the angle theta, which is along the x-axis, and then use that value, substitute that value for the real and imaginary component, comparing that with a complex plane. That form of representation is nothing but called the polar form of a complex number. Both are essentially the same, nothing different. It's just a different representation. Any questions so far?
No, sir.
Dave? Not sure if we lost Dave, but fine. We'll go to other interesting aspects of complex numbers probably in the next class, because these are some of the interesting tricky elements of calculation, and probably I'll try redefining the polar form one more time to make it even more interesting or much more simple to comprehend. But if you guys have no other questions, let's spend a little bit of time dealing with some of the basic trigonometry stuff that we already know, which we'll end up applying here. So there's a rule called composite angle rule. Would you recall, Dave or Prisha? Since Prisha is only able to talk, would you remember what exactly is that? In case of trigonometry, let's say this is my right angle, this is my theta. So so we know that, okay, this is A and this is B and this is C. We know that sine theta equal to A by C, cos theta equal to B by C, and tan theta equal to A by B. There's a rule called rule of composite angle. I'm just trying to recall if I'm calling it out correctly. Yeah, it is. What is a composite angle? Do you remember by any chance?
I can't recall. I'm
Okay.
not sure if I've been before.
So when two angles make angle A and angle B together make 90 degree, they are called composite of each other. Okay.
Aren't they complementary?
That's exactly the word. I was kind of struggling. Complementary angle. Yeah, this is the rule of complementary angle. Now, do you remember or do you recall what the rule I'm referring to?
Yeah.
What is that?
It's the entire triangle has to be equal to 180.
That is okay. That is a universal rule for any triangle.
Yeah.
I'm saying that the rule of trigonometry for complementary angle. Yep, my bad. I was using a very wrong word.
Isn't that just the two angles equal to 90 degrees?
this is two angles equal to 90 degrees, and it says sine of theta equals cos of 90 minus theta. This is the rule of complementary angle. And you'll ask me,
Okay.
you, right? So any angle that you take, sine of that is nothing but the side opposite to that divided by the hypotenuse. So, and cos of that any angle is the side which is adjacent divided by the hypotenuse. So this rule of complementary angle says in any triangle, sine of theta is equal to cos of 90 minus theta. So if this is theta, this is anyways 90 degrees. And as you rightly said, sum of all the angles is 180 degree. So this will be nothing but 90 degree minus theta, correct? Yeah?
Yeah.
So sine of theta, if I look at the same angle, sine of theta will be, this is theta, so A by C. And what is cos 90 minus theta? This is 90 minus theta. What will be the cos of that? So side adjacent to that, divide by hypotenuse, which is cos of this angle. See, sine of cos of this angle will be this divided by this. Cos of this angle, when we take this angle into account, cos of this angle will be the side which is the base of that angle by the hypotenuse. So it will be A by C. So as you can see, sine of theta, which is A by C, sine of theta is A by C, is also equal to cos of 90 degree minus theta. 90 degree minus theta, A by C. Yeah. So that is the rule of complementary angle, which says sine of any angle is equal to cos of 90 degree minus that angle. Yeah.
Yeah.
Dave, did I get you back?
Yeah, sorry, sir. I was having issues.
Okay, no problem. So Dave, basically, since we went to this unit circle and we kind of tried brushing up those concepts, so we could not complete or cover everything that we wanted to cover with respect to complex numbers today. So I just briefly touched upon what is a rectangular form of a complex number versus what is a polar form of a complex number, and then tried relating that with the unit circle that that we talked about. So right now we are just kind of brushing up some of the concepts of trigonometry, basic trigonometry that will be applicable for us when we go to the last part of complex number, which is more around playing with the polar form of complex number, then multiplying with I, multiplying with 3i, minus 3i, whatnot. Yeah. So we are just kind of doing a quick recap of what we know with respect to basic trigonometry, and then we will end up probably applying those concepts in the next class to finish the last part of complex number. Yeah.
Okay.
So Prisha, this part is clear. Okay. Now how this helps? Any clue? Why do we need to even worry about knowing the rule of complementary angles?
I'm sure it like makes something easier, but I'm not sure what that something is.
So I kind of try navigating you guys to things which are easier in nature, right? I mean, things that we can relate. Now let's look at this. If I ask you what is the value of sine 0 degree, you would know it. It's 0. What is the value of sine 30 degree? Would you know it? Would you remember it? 1 by 2. Okay, so I don't prescribe you guys to remember it. I remember it because I've done it probably maybe 1,000 times. So we'll come back to the rule of complementary angle. I certainly need to buy a new board. This guy is breaking apart or falling down. So let's keep that rule of complementary angle in one corner, which says sine of theta equal to cos of 90 degree minus theta, and I'll show you guys what is the relevance of this. Okay, what is the practical use of this? If I ask you what is the value of sine 10 degree, would you remember? Probably not. It's not fun, and we don't really need to invest so much energy for memorizing those things, right? That is available in the in the calculator at our fingertips, right? So now let's look at what is the significance of this one. If I ask you what is sine of 0 degree, any guesses? It will be 0. You have to just visualize this right angle triangle. See, this is theta. Sine of theta is this. Let's say this is A, this is B, and this is C. Sine of theta is A by C. When I say sine 0 degree, what essentially I'm talking about? I'm trying to move this line closer to the horizontal line, correct? When it will become 0? When it literally falls on this guy, correct?
Mm-hmm.
Yeah? That means this length and this length will probably become the same. That's the only way you can get a 0. Right? This length and this length will become same, and this length become 0, right? Even if this is 0.0001 centimeter, let's say, this is still not 0, right? This is more than 0. Maybe 1 degree, maybe half a degree, maybe 1/4 of a degree, right? So, if you look at sine 0 degree, meaning this divided by hypotenuse, and for this to be 0, this line will literally fall on this line. So this height will become 0. So 0 by anything gives you nothing but 0. Yeah? Now, so now you know that sine of 0 degree, 0 degree is nothing but 0. I'm saying that you have a rule of complementary angle, which says sine of theta is equal to cos of 90 degree minus theta. So sine of 0 is cos of 90 degree minus 0. So cos of 90 is 90 minus 0 is 90. Cos of 90 degree. So whatever value you got for sine 0, that will be same as value of cos 90 degree. So if you say sine 0 degree is 0, cos of 90 degree will be equal to 0 as well. Sine of 0 equal to 0, cos of 90 equal to 0. We could just put that value here. Yeah? This is one example. Are we all clear?
Yeah.
Yes, sir.
If I say, what is the value of sine 30 degree? Do you guys remember how much it is? Sine 30 degree.
1/2.
How?
Are you like,
Yeah, I mean, see, when I say how, I'm just trying to find out how somebody found that out, right? Or how was that derived? Now let's look at it. This is my equilateral triangle. When I say equilateral triangle, I'm saying all the three sides are same and all the angles are 60 degree, correct? Yeah?
yeah,
Now what I will do is from here I'll drop a perpendicular. So ABC got split into two triangles, ABD and ACD. Yeah. So one triangle which is green and another triangle which is blue. So I had an equilateral triangle where equilateral meaning all the three sides same, all the angles same, 60 degree each. I have dropped a perpendicular from here to here. This meets here. Now I'm saying, you guys know what is congruence, right? What do we mean by congruence? Do you guys recall?
Yes.
Okay, so when any two thing is told to be congruent, meaning they are exact copy of each other, meaning they have every property matching. Okay?
Right.
Yeah.
And there are some theorems for congruence. Those are called SSS, ASA, SAS, RHS. Meaning, I mean, we are not going to prove those theorems. I have proved that in the past, and if needed, I can prove it again. But what I'm saying is, if there are two triangles, what this theorem says, when the two triangles have all matching sides, they'll be congruent, meaning other properties will also match. If there are two triangles where two angles and the side between them match, they are congruent. If there are two triangles where two sides and the angle between them match, they are congruent, meaning every other property will match. So here, and the fourth one says, if there are two right angle triangle, this is for right angle triangle, where the hypotenuse and one of the side matches, they are congruent. So here what I did, I had a equilateral triangle, I dropped a perpendicular from here to here. So this is 90 degree and this is 90 degree. So both the triangles we are looking at, angle ABD and triangle ACD, both are right angle triangles. And if you look at it, this side and this side are same because it was part of the original equilateral triangle. So hypotenuse are matching for both the triangles, both the right angle triangles. And this side is anyways common. So these two triangles are congruent, meaning this angle is anyways matching because it was part of original equilateral triangle. This angle is also matching because both are 90 degree. And this angle and this angle will also match because now both are 30 degree. Yeah? Because of congruence, we found that these two angles, basically in an equilateral triangle, if you draw perpendicular from the opposite vertex to the side, this splits into two congruent triangles, and these two angles become same, 30 degree. Now, this is 30 degree and this is 30 degree. Now you pick up this triangle and find out. So another thing we found is this side and this side also same, okay? Because these two triangles became congruent, so these two sides also have to match. These two sides are already matching. This is common. So we found this side and this side are same, and this part is nothing but if this whole length is x, this whole length is x, this whole length was x, so this is x by 2. Yeah? Am I going way too fast?
No.
No? Okay.
That's right.
So basically, summary, okay, so now this is x by 2, so, and this is 30 degree. So sine of 30 degree is nothing but, if this is 30 degree, sine of this angle will be equal to side opposite to this divided by this, hypotenuse. Side opposite to this is nothing but x by 2 divided x by 2 divided by x. So this becomes x by 2 into 1 by x equals 1 by 2. Yeah. So again, what did we do? We took a equilateral triangle, dropped a perpendicular from here to here, and then we found that when you do that, this breaks into two congruent triangles. From that we found this and this angle are 30 degree each. Now, because both are same and total is 60, so this will be 30, this will be 30. And this side and this side will also be the same because of congruence thing. So your sine of 30 degrees, this divided by hypotenuse, so this is half of this. So half of this is nothing but, it gives you a half. So sine of 30 degrees is 1 by 2. Now, how did we get sine of 30 is 1 by 2 is fine, right?
Yeah.
Yeah? Dave? This part is clear, right?
Yeah.
Now, if I got sine of 30 degrees 1 by 2, 1 by 2, we know that sine of theta is equal to cos of 90 degree minus theta by the rule of complementary angle. Sine of 30 will be equal to cos of 90 degree minus 30. which is 90 by 30 is 60, cos of 60 degree. You just learned how to find out the value of sine 30 degree, or what is the value of sine 30 degree, and you can by default say that okay, that is equal to cos of 60 degree. So sine of 0 is 0, cos of 90 is 0, sine of 30 degree is equal to 1 by 2, cos of 60 degree equal to 1 by 2. Now one quick riddle. If I say sine of 42 degree is, let's say, 0.36, what is the value of cos of 48 degree?
Did you say sine of 42 degrees?
Yep. If I say sine of 42 degrees, I'm just making it up, 0.36 let's say, what will be the value of cos 48 degree? It will be the same, because 48 is nothing but 90 minus 42. Yeah. So that is where this rule of complementary angle helps you derive a lot of related information. Okay. So I mean, I'll not be surprised. I mean, I probably have seen a couple of questions where in the city also they'll just give you value of one sine of some degree, and they ask you to find out the cos of corresponding complementary angle, or by visualizing the unit circle and then finding it out. Let's say if you know sine of 45 degree, if they ask you to find out cos of 315 degree, that also you can find it out. You have to just visualize that in a unit circle, which quadrant it falls into, get the absolute value and put the right sign. Yeah. Was it okay to digest, or?
Yes, sir.
Okay.
Yes, sir.
Okay, so let's pause here then. So just a quick summary or recap of what we did today. We just went back to unit circle, tried relating that, tried recalling what is unit circle, what are the things that we need to know, how do you find the x and y coordinate of any point on the perimeter in a unit circle, and then we came back to complex number, and we kind of touched upon what is the basic difference between a rectangular form and the polar form of a complex number, and we just touched the we call it tip of the iceberg. So we just touched the very high level part of it. There are a lot of interesting concepts that we have to go through practice. So that's what we'll do in the next class, and that will bring us to the end of the the third unit, which is complex number, after the next class, and then we'll resume, or then we'll start from unit 4. Yeah, which is around algebra, if I'm not wrong. All right. And Prisha, like the deal that you and I have, you will go through the video and let me know what are the topics that is requiring some clarification, and 7:20 to 8:10, that's the time window you have on Tuesday and Thursday when you can call me, or just send me a message and then we can hop onto a Google Meet. I'll be joining from my phone only, but yeah, I'll certainly try to do whatever I can. Yeah.
Okay, thank you so much.
All right. Take care. Enjoy the rest of your evening. Heading towards the weekend. Have fun.
Thank you. Bye, sir.
All right. Bye bye.